Bernie gave us a quick overview of optical things at CAT 17 last year. I think we all went away and we said...
I'll be much further on by next year.
Yes, we
which,
said...
as you'll see by the modified title, I may not be.
We said to
oh
Bernie,
yes, sorry, of course.
Will it do... I mean, he talked about optical, and we said, will it do television? I don't know, he said. Well, he does now.
That's Brian's fault for that. Brian suggested it. Anyway, afternoon all. I'll try and speak loudly and quickly if we're late.
We're about on time.
I've said a work in progress because there's quite a few things. TV is new to me and digital TV certainly is. And there are some errors in these slides which you may pick up on that I haven't seen. So a work in progress is really a better title. I want to go through quickly so that hopefully I can get some feedback at the end because there's a lot I want to hear as well. How do I get it together? That one? Oh, there we go. Yes, okay. So my background is relevant to this, is to have tried audio on optical, and that really comes out of a visit up to seeing Stuart Wisher up in Newcastle and all the people up there. And it was really amazing because it was just so little power really to get results. And so I got into that. I also like the Minitune software. I'm a hardware person who really doesn't like software, but there's always exceptions. And I think that Minitune software just, because of the near real-time outputs on the MER and the Constellation, I thought that was really worth following up. So, I mean, the two come together quite nicely, except I didn't think about that, but it was mentioned, has anybody done it? And I don't know if they had, but I don't think they had. So I got into it that way. So that was my background. When you're using audio, to give you an idea, I mean, you're not talking, this shouldn't blind anyone, no guarantees. But that will get, oh, sod it. That will certainly get 60 kilometres, sorry. That will certainly get 60 kilometres. That's 350, 400 milliwatts input. And 350, 400 milliwatts.
That's infrared?
No, just red. Just red. But I mean, Stuart had done a lot of work on infrared before he was ill. And what you find with audio... Well, yes. What you find with audio is that if you're using A4 size Fresnels, i.e. giving you plenty of gain, then you can hear a signal at a point where with the naked eye you can no longer see the LED. So I mean, that's amazing how sensitive that is when you're just using photodiodes. So I mean, that's the, as in with radio, it just keeps you really interested that such a low power can get you all that way. So anyway, after Brian mentioned about doing this, I got really interested. Now, the obvious way to generate is to take the baseband signal, if it were available, and Heather's been really helpful in talking about that to me. But I figured I really ought to try and do some work myself before I even asked to go any further. So that just left me, and I'm an analog engineer, so it suited me to either use the IQ output or the ugly output. And although I think A and B are the best ways of doing it, I went for C because I had some crystal filters that came from Burkitt that are about 300 kcs wide, 400 kcs wide. And if you put 17.5 megs, which I notice the software will do on the Raspberry Pi, I tried going down to audio, by the way, right down, and you get to about 1 meg, and then it starts to do a very strange thing. So that was a shame, I got so close. I need to go low in frequency because the receive sensitivity of the diode, because of its self-capacitance, I'll come on to this, but it starts to drop off above a kc. So, you know, I'm deliberately wanting to go very low, and so I end up going down to 150 kilosymbols actually. But you can see for 2 meters, something I want to try is using these crystal filters off the ugly output. But I'll just put that in just for the interest. That's a good shape, and across the room it decodes okay. But what I decided to do was to use that and just use down converters, and then after I transmitted it, up converters from baseband up to 2 meters, so I could use both the Raspberry Pi and the Minitune, which is what I've done. And there's quite a few interesting aspects of that were new to me, but it has worked. But there's some things I want to ask for advice here.
What do you call baseband?
I really meant the initial video. What I really wanted is the video with error correction before you translate it up.
In frequency terms, in analog frequency terms, it's DC up or 100 kilohertz or what?
Well, you're the TV man. I don't know. I want the basic TV signal before you translate it up to RF.
Composite video.
No. You want it digital. Sorry. So what frequency do you drive the LED driver with? What?
I'll show you that in a moment.
Okay.
I'm using the excuse of ignorance all the way through here. My ignorance, by the way.
I do it all the time, but it works.
Yeah, so I think the only thing, so that slide is really an indication of what I'm doing, with the exception of, you can imagine the optics are at least narrower, 1 degree or narrower. So you really want instant feedback when you're listening to a signal. And the obvious thing to do, given that I've got a carrier frequency of 120 kilohertz or so, the obvious thing to do was to use an AM radio. And that works very good to just line up on noise and then swap over to the Minitune setup. And that's all very effective. So I just put a couple of pictures in. It's what you'd expect, the Minitune, which I really ought to have the shield, the display shield. And as a diagram straight into the filter, and effectively down converted. Let me go on to the next slide. So I'm trying to rush through this. Let's just go on to transmit. So I'm coming out at 17.5 megs with the horrible spectrum on ugly mode, going through the filter, which is wider than I want for 150 kilosymbols. I could go lower than 150, but I found the picture was so awful, it didn't seem worth putting all the effort in for a picture that bad. So 150 seemed okay. So what I've done, I've obviously moved it across, so at least one edge of the filter gives me a decent shape, and but not the other side. But by the time I've down converted it, I can then put a low pass filter on it and just take those out, and I end up with that. Which, because on optical, you're not worried about anybody else's channel. There is nobody else's channel. So the spectrum really doesn't matter that much, except from an efficiency point of view. Or that's what I try to keep telling everybody. And just in case that's of interest, so I'm using a switch capacitor filter. And you do things independently to what everyone else is doing. But when you come and look at the part numbers, you find it's exactly what you've used on the BATC products, and I did exactly the same with the IQ modulators. I bought 2 lots in, and below me they were both the ones you'd use, so we obviously go to the same place for the bits. So I only put that in as an indication of how simple it was. But again, I'll try and move on quickly. I can always go back to some of these, and just a bigger version of what I've got. Now, here's the first mistake I know I made. I thought on 150 kilosymbols it wanted to be plus or minus 75. So yes, I know I should be further up, but it has worked. But being a hardware engineer using software, I can really blissfully say I don't know why and not worry about it. But well, that might be a relevant thing to come back to. So I'm just using that as an exciter. When I come out, there's 2 sources of LEDs that have been fairly common that I wanted to use. One was the Golden Dragon series, and the other that came along by chance, the the flat light LEDs that were used in projectors, and which an American company was obviously breaking down old projectors and selling them a few years ago quite cheaply. When Brian first mentioned putting optical over DATV, I did try and hit these both with a square wave just to see if the corners got rounded off. And on that occasion, with the flat light, it did. But I remeasured it last week and everything seemed okay. So I'm a little bit surprised at that. Is there anything else to say about those? But those are currently available. Actually, all the work I've done, because I thought the flat light was not going to be quick enough, has been with the 1.5 watt device.
Are these readily available on eBay?
Yeah, they still are, even the flat light is. And I calculate you should get 30 kilometres with this and a 4 Fresnel. So by the time you've gone over to the flat light, then you can see the distance should get quite large. But anyway, the measurement I did again this week is that. Now, the three graphs are virtually identical. So I don't know what I did wrong earlier in the year, but it does look as though the flat light is fine at 200 kilohertz. So that's good news, really. So I can go on to that at some later date. There's lots of things like that where I can do improvements. So I'm really pleased that with the results I've got at the moment, because they're already adequate. And what you saw before was the current through the LED, which normally ties up pretty well with the optical output. But this would tend to disprove that. This is looking at the response into a photodiode and then into a scope, and it does look as though there is some degradation. And as you would expect with that circuit I had, it's an active pull down. So yeah, so that should be sharper than this. But anyway, they're still showing that the results are good enough to continue with. So far, nothing to stop me going forward. Normally I would use a power FET, just to modulate the device, but I like things that are cheap, and you know what the Chinese are like on eBay. So for no reason at all, I bought a few of these 15 watt plus 15 watt stereo amps. And I thought, I wonder if they'll go up to 200 kc. And sure enough, they're only about a couple of dB down. So I thought, well, I'll carry on using that as my modulator, since I only wanted to drive the 1.5 watt Golden Dragon. So I did put a little bit of compensation in there, and also because I wanted to keep it linear. Even though there isn't anybody in the next channel, I thought at this stage it was sensible not to worry about efficiency. So what I actually did was drive directly off one of the bridge outputs to give me that half rail bias. And then, because these are current limited as well, I thought, well, why not use the other stereo half and just sum the two together. And I'm feeding through a resistor because the LED voltage is fairly constant. And so I really want to establish a voltage there, since I'm going to drive from that. And that seems to work okay. Not particularly efficient, but and not what I would do if I was doing it again, but it has worked okay. So if you come on to the receive up converter, I'm coming out of the receiver, which I'll come on to, the head module, at what I would call quasi-baseband anyway. So then I'm going up to 17.5 megs again, because I want to translate the signal up in frequency. So I didn't want a double sideband signal, I wanted an exact copy. So in effect, I'm again generating a single sideband signal at 17.5 megs, and then going into another mixer to take me up to 146.5, for no better reason that that's what I've been used to when I was playing with a mini tune in the first place. And again, that's worked okay. So again, so far okay. Now the head end, I'm using one of the Finley receivers. I'm using the photodiode in modified, using the photodiode in voltage mode. So at audio, at about 1 kilohertz, the impedance at that point here is definitely at least 40 megohms. You can check that with shunt resistance to ground and see what difference it makes to gain, and it's making very little at that. But it does mean that the diode capacitance, which, oh no, I'll come on to that. So I'm just doing that. I've come off the source of the FET where I normally come off the drain, but again to avoid as much feedback to the input that would lower the impedance as I could. And the op amps that I used on the Finningley were really quite poor frequency-wise, so I've put these, well, I call them near enough video amplifiers, but you know, these are the high frequency ones. When I did that, I found I'd gone from one extreme to another, and there was loads of noise coming out there at 2 meters, so I thought, well, I'll do some roll-off on the HF side, but that's really trivial. The relevant bit is a roll-off on the low side, because as I say, the gain is falling away very quickly. And the gain is falling away quickly because of the diode capacitance and I guess the gate capacitance on the buffer. And at audio, the tendency is to reverse bias to reduce that. So I'm reverse biasing at 8 volts, so I've got about 3 puff. And when you do that, you get that top uncompensated response at the top, where this is about a kc, where it starts to go down. Now you could say, well, we're 20, 25 dB down here. But actually, it's not as bad as it looks, because if you look at the noise output of the receiver, the actual sensitivity is really going to be that minus that, I suppose. So you know the gain is going to be down, but it's, I say, it's not as bad as it looks, because at 40 megohms there's a lot of noise coming out the FET. So the mere fact that the capacitor is loading it right down means the noise gain goes down as well, if I've said that right. Now again, this is why I've got it totally wrong. I'd said plus or minus 75, and I realise I should have said 150, i.e. way off to this side, so I don't know how that works, but it does. But you can see that one RC network is quite effective. My analyzer won't go down to DC very flatly, so that is just a straight through response at the top. So you see I'm down to at the most dB and a half. So I was quite pleased that I thought I got a flat response. So then across the bench, this is what I get. But I never get greater than 18 dB MER, but presumably that's because I'm really restricting the signal too far. But I'll come on to that, that's why I want to open it up and see what people's views are. But it is working okay. I mean, I'm quite pleased with that. I would have lots of questions about these parameters here, because they don't seem to do a great deal for me. Oh, am I only discovering what everybody else has discovered? Oh, great stuff, good. You know, if you've got a guilty conscience, you always think it's you.
No. Just press the button marked expert.
But however you look at it, there's the issue. I mean, I was quite intrigued to see each point actually break up into 4. And
yeah, I can explain that.
well, when I thought everything was okay and I wasn't, and I thought, well, it's a crystal filter and group delay, and I sort of moved things around, didn't change at all. But presumably it's the issue I talked about earlier, that I'm restricting it far too much. But nonetheless, consider, I mean, ignorance is really great, isn't it? Because you just plough on regardless. And I mean, this is good enough to be doing useful work, which is why I said to Heather that it'd be really nice if I can get direct output from the Raspberry Pi, but there's loads I can do yet. Anyway, now I've got to admit another problem we had. Jenny and Phil were good enough to come out and try and do a trial over, well, we started at 4 kilometres and failed. Well, I really don't know why. There was something really basic, several things that I hadn't thought about, and so we gave up. So I couldn't come here without any figures for what we could get. So I thought I'd better set up a test range at home. So I did a 30-metre range, I used a lead which you see in the other room, running 1,000th of the current, so 30 dB down, given that the voltage stays constant across the lead. Bit of an assumption. And there was no Fresnel lens at the far end. So for the first time ever, for me using this software, where I was only that far above the noise, in that 0.5 kilohertz bandwidth, admittedly, I thought that was quite good, really. And purely by chance, I was right down at the limit of where it was going to stop working. I couldn't have wanted anything better. So now I've got my reference at a lead at 1,000th of the current and 30 dB down on the optics. And that 30 dB down is very pessimistic, sorry. I talked to Stuart Wisher during the week and didn't tell him what I was going to say here, and he reckoned about 35 dB for a Fresnel lens in front of a standard lead. If you got the beam width right from the lead, but that, I don't think we've time to talk about that. So there we are, that's my calculation. I can't see anything wrong with it. 30, that works out, doesn't it? 30 meters, 30 dB up will take you to nearly a kilometre. And then remember, this is with a 1.5 watt lead. So if we use the flat light, which is above, 12, 13 dB stronger, potentially we should get a good distance. Now, when I look at this right on the limit and look for the lead, I definitely see it. So it's not like the audio case where you look at where when you're down at this sort of level, you don't see the lead at all without binoculars. With this, you definitely see the lead. But, you know, the figures are working out really good. And those distances for the power sort of equate to what you're saying earlier on, certainly on 70 megs, and certainly on the 5.6. But, of course, you need to be out in darkness. You know, you get a glorious summer day and you ask somebody, or somebody asks you what you want to do, and you say, I want to wait till it's dark and go out. It's not very good. Anyway, I say I've rushed through it. So that's all I was going to say. It was just meant to be really an introduction. I'd hoped to be further on than I am compared to the talk, which was at Finningley. I don't think I talked about this at last year's BATC. That was just the audio, wasn't it? But nonetheless, Finningley was a long time ago, and I really thought I'd be a lot further on than I am. So there we are. So where do I go from here?
I've been asked a question by text from somebody I'm not surprised was watching. I've no idea what the question means, but he said...
What does it say? What's it on about?
Could you ask about how it's affected by scintillation, please?
Oh, damn, I meant to mention that.
I could ask, but I've no idea what it means.
I bet that's Rob. Of course.
No, it's John, G4HJW.
Okay, definitely. That's the one thing that my short test range isn't going to show up. But once you get out to several kilometres, I mean, I've got a 10k test path. And if you're out on a summer's evening when it's dark, with the land still warm, the amount of scintillation is enormous. So yes, that is a really good question. So I do need to do the test.
And would scintillation appear as a fine sort of multipass, sort of phase distortion, do you think?
Who knows?
In which case, this wouldn't like it.
Well, that's what I was going to say. I don't know. We're now back to, well, let me go back. We're now back to what the mini-tune does. And I have no feel, really, for what it's doing, which is lovely in some ways, but then gets frustrating when you really do want an answer. Yes?
Are there any health and safety issues if you're running the LED flat out through a Fresnel lens from people who may happen to be looking at it from a distance, say through binoculars by mistake?
Well, yeah, it's not like you start off, if you're going through the Fresnel, at only, well, the width of an A4 sheet. So you never get anywhere near what you get with yeah, absolutely. So I do wonder about with the flat light at 20 odd watts, But then, what if somebody walks in? I mean, what's the difference between that and me walking in front of that, apart from the fact that I don't know where I'm going? So I assume I would never use a laser for the reason that you said.
No, I wasn't thinking of a laser. I was thinking of your flat light, flat out, as it were, through a Fresnel. I mean, it's going to be a fairly bright signal, isn't it, coming out? That's the whole point of it.
Well, now, funnily enough, once you're going through the Fresnel lens and you've got the beam width collapse, while what you say is true, an associated question, I'm not trying to dodge the question, but an associated question is, well, isn't that going to give problems to people everywhere that are out there? But it's so narrow that it's amazing. You've got to be right in front of it at quite a good distance. And also, to see backscatter, you've got to be, unless it's a particularly misty day, in which case you're not likely to be doing any tests, you've got to get right behind before you see backscatter, which is quite useful for seeing how you've got it set up. But I can't deny it's a fair question.
Mm-hmm.
I presume as somebody who's never done optics, there's all sorts of challenges.
Well, that's my position. I was never interested in photography, just radio.
No, but you've done optical communications before. A lot of us haven't. I guess we've got that learning curve to go up.
Yes, there is, because, again, there's really not time to say much. With those two LEDs on that I showed you on there, they've got a 120-degree beam. So when you think the standard Fresnel lens has a focal point of about 300 millimeters, you can imagine you are really grossly over-illuminating it. So you have to have a secondary or primary lens, I never know what you want to call the one, a bullseye lens in front of that. But with these low-power ones, with the 10mm LEDs, of course, you've got the lens in front, and you can buy them at different beam widths. So that one matches the Fresnel quite well.
So would you be prepared to write this up for CQTV?
Yeah, well, yeah, certainly. And I mean, I hadn't put anything on the forum because I was too embarrassed given how many mistakes I've been making. But yeah, I'll do that. I mean, there ought to be something on the forum, really, but it depends if anybody else is interested. Yes?
Where do you get your Fresnel lenses from? Expensive.
Well, a few years ago, Poundland and places like that, the view being that a lot must have been made that had a slight flaw. And of course, for what we use, we don't need a very tight focus. It's not the same as you would want for a photograph because of the die size. But these days, either on eBay or Smith's, I think, have them, some of the bookshops.
How much are they?
So I think those are about £5. So, but it's great as you're getting older. You need them anyway to be reading a newspaper. So, I mean, they're multifunctional. One I didn't say, since you mentioned about the optics, but you all know about this since you're in TV. The two LEDs I showed before, the flat light is a much greater area. So, with the same optics, you can only collapse that image, if you like, down to a larger area than the smaller one. That's just basic maths, I guess. So you wouldn't get, and I have a graph. Well, no, I'll do that. I've got a graph. I've got that. So that was the two at 30 meters onto the living room wall, and with a cat trying to get at them up the wall. And you can see, well, you can see the difference and those are collapsed down as far as I could. So there's an element of that. But you can see that that one is still brighter. You could tell it was right in the middle. It was still brighter. And that wasn't at 20 watts. That was only about 8 watts. So I'm interested in playing with all this. I've not bothered too much about going out portable, but depends what interest there is. I mean, I would go out if there's anybody else interested. So.
What's the legality of running this?
Sorry, what?
What's the legality of running this? It's obviously not in terms of an amateur radio license.
There is no requirement for a licence at the moment. So, I mean, that's another good thing. You don't need to be... In fact, there's a user group. Name I forgot now. Can you remember what it's called? Nanowave, that's right, Nanowave group. And of course, you know, most people on there are amateurs, but there's no requirement to be. So, I mean, that makes it... So, this would be a good thing for kids at school, I think. Could make some really... Well, it's... Why are you laughing? I mean, I know you should strangle them at birth, but you know, once you've let them get to that age, once you've got them to that age, because the circuitry can be really simple.
Yes.
And they can blind themselves with it, of course, going back to your camera.
Thank you, Bernie, for next year.
But I was wanting to ask loads of questions, but I know we've run out of time.
Well,
So.
no, we're okay for a couple more minutes if anybody has got any. I mean, does this inspire anybody? Is there a little bells ringing? Yeah.
It does certainly.
I'll put my hand up on this one, I think.
When you put the comment back backwards, is you going to explain that comment?
Sorry?
Dave said he had the answer.
Yeah, I'll take them on.
Oh yes. So are you surprised I got?
Your four.
Yes. Go right back to the beginning. It's,
Right, this is the point.
oh, have you got it?
This is relevant from two perspectives. The 4 dots here represent what the previous symbol was. So if the previous symbol was that one, it would be that one. If the previous symbol was that one, and so on. And it's caused by an imperfect filter shape, generally too tight, and you get inter-symbol interference from the last symbol to the current symbol. And it goes, the 4 constellations within the constellations are what the previous symbol was. Now, those of you who've got Portsdown shop boards of version batch 1, batch 2, and I think batch 3, will sometimes see this on symbol rates under 1000 because we made the filters slightly too tight on that, and there's a modification on the forum that you can do that collapse those 4 in if you've got that problem. Now, I think for
It
Bernie,
all comes out now in the wash, you see.
yeah, it does. I think for Bernie's problem is that filter you're using is too tight or too close to 0 megs on the left-hand
Well,
side.
what's really good about that is, because remember I wanted to be as low a frequency as I can because of the expectation that the receiver response is falling away. I could go to a current operated photodiode, but when you see the range that I predict, and that's not with a flat light, I think now I can say, well, no, you know, this is workable.
Yeah,
so what I need to do is to drift, is now to put the, is to go from 100 odd to 200. And then my filter, those crystal filters are ideal because they are 300 kcs wide.
Now, the effect of that at good signal to noise ratios, the effect is 0. You just get a pretty pattern on your constellation thing. As you get a weaker signal, you can imagine these dots sort of get a noise area around them. And that would probably give about 2 dB of degradation, 1 dB, 2 dB of degradation, because the noise area you are starting with is larger before you go outside the quadrant and you get into error correction. So it's 1 or 2 dB. It's not 5 or 10 dB, but it is that last little bit. 1 or 2 dB in terms of range of how far your signal goes isn't very much.
Right, here's another question for you. I thought I needed to put a single sideband signal into the receiver, as you in effect do when using the IQ output. I don't know how many people have thought about it, but you know your transmitters are phasing transmitters using third method SSB. And I would never have guessed that until I did some work before I come on to this. But I never hear people in the group here talking about the fact that it's third method or Weaver. But you're using Weaver transmitters. But
I think it's QPSK,
But it's a Weaver transmitter, and and if you have any doubt about that, your carrier frequency is right in the middle, and you tell me how you... Well, I mean, it is. You think about what you're doing. It gets hidden on digital because you're doing all the manipulation of the modulating stream digitally, so you don't see it. And what was really interesting, I know I'm going off at a tangent, because people working on digital transmitters are now of a younger generation that worked on SSB 50 years ago, there's a loss of communications. In the past, people would say that's phasing and they have no problem. These days, because there's more complexity, engineers come at it, or especially the people who are coming up with a base system, they come at it from a mathematical point of view. So the word Weaver or phasing means nothing to them. It's a really interesting point. If you like meaningless bits of information.
Thank you very much, Bernie. And I think there's a few of us who there's some. Yeah, that looks interesting. Maybe we can get an article in CQTV to try and pull the knowledge together. And if there's some boards to be made and this sort of stuff, of course, we'll look at doing that.